so we can, oh, it works for the creation 2. So, C out 2. C has changed again, still the same object. All right, let's do this. We'll follow this example here. Okay. All right, torch dot rand. You can make a new one. Out equals C. All right. And we can print this again. And it will be a different value of C. This time, the identity is identical as it always has been. Yep. 960, 960, 960, 960, 960! They're all 960s! And then at the bottom, though, we've got a different value this time, right here. Ooh, yeah. Okay. Neat. Straight up, if you didn't know this whole time, you can do something like this. I thought this was going to be really boring right here, but I was actually pretty excited about it. All right. Let's do a copying tensors, which is kind of... This is not the same thing as referring to the same tensor. So that's what we were doing. We were doing references. Now we're going to do copy by value. Let's do copy by value now. All right. We'll do copy by value. Let's quit this. MV tensory to copy by ref.py. And then we are going to do vim. This will be copy by value. Pi import torch. A equals torch dot. What do you want? Ones? Okay, ones. It doesn't really matter. Let's do a whole bunch of ones, one by one. All right. B equals A. Now this is not a copy by. This is a copy by value, not by value. This is a copy by reference. So B is now A. B is now exactly A. The music is killing the stream, bro. Yeah. It's... Wait, how long is this song? There's only 30 seconds left, don't worry. There's only 30 seconds left. No worries about it, no worries. Hey, Kevin McAllister. Yeah. Okay. A01 equals 561. We can change A. B is also altered. Yes. So this is not a copying. This is not copy. Does not copy. Yeah, see, exactly. If you were to separate a copy of the data to work on. Clone, here we go. Now we're going to copy by value. That only took 10 minutes. I meant unrealistic run in Pytorch. Oh, got it. Yes, okay. Yes, unrealistic run on a computer, like your computer would crash. Yeah, it sure would. It would eat up all the memory. It would try, and then it would out of memory error. It'd go out of memory error. Let's do a clone. There's a .clone method right there, you guys. A .clone method. All right, so let's do B dot equals A dot clone. So these they're cloned, but B is going to be different, right? So you can print B. Assert A is not B. All right, right. Torch.eqs, but still with the same content. Yes, exactly, because we cloned it. All right, torch.eq. That's pretty neat. I'm actually kind of curious about this one. Print torch.eq, A comma B. Let's check what that looks like. True test. Okay, la 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 la, Pytorch, la la la. A equals, okay. So we did that here. We updated this here. And then we compared the two. However, this time, if you mutate A, it's going to be different. All right, let's bump over here. Print B is going to be B different. Let's find out. This is what I want to see. I want to see this. Random German word plus maybe some adjective. Sure. Yeah, exactly. Stark, Freen, Fern. You come up with a whole bunch of names. All right, so what did I want to see? I wanted to see that A and B are different. Okay, so 1, 2, 3. Yeah, here's 1, 2, 3, 4 right here. And B is still stuck on 4 because we cloned it by value. All right, we're learning new things. The .clone method, right there, the .clone method. Easy performing a computation in your model's forward function, where gradients are turned on for everything by default. However, if you want to pull some values midstream to generate some metrics, that kind of ended early. In this case, you don't want the cloned copy of your source tensor to track gradients. Performance is improved with autograd's history tracking turned off. For this, you can use the detach method on the source tensor. Okay. Detach.clone. You detach before you clone. Got it. Okay. Detach before you clone. Okay. La 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 la. R equals A.detach.clone. Like that. We clone A, label B. Yeah, we already walked through this. We walked through all this, right? The detach method detaches the tensors from the computation history. Yeah, so we don't have it on a graph anymore or anything like that. Does what next with the autograph is off. It does this without changing A, so you can, yeah, then we print A again at the end, and it retains the grad true property. Sometimes you'll need to change the shape of your tensor. Below, we'll look at a few common cases and how to handle them. All right, you guys, so let's get into tensor shaping. Close that. By tensor shaping. Let me do reshape.py. Okay. So let's reshape. I think we're gonna use the .view method. We'll probably be using the .view method to reshape it, right? Is there gonna be a .reshape? I don't know. Let's find out. All right, so we say A equals torch.rand. Do a simple torch there. A.view is gonna be a method. What about reshape? Shape is definitely a method. Is reshape a method though? It is. Reshape is a method. So what's the difference between view and reshape? That's my question. All right. Changing the number of dimensions. All right, there's in case you might want to need to change the number of dimensions, passing a single instance of your input model. Yeah. So if you got a batch, for example, model generally expect batches right there, right? We know it's not. Reshape is good. Reshape versus view. I'm actually curious, like, so reshape versus view. Versus view. I'm curious about the difference. We're gonna find out. There's also unsqueeze, which you taught us that one, Neva. And I don't usually know when to use it. Imagine we have a model that works on a 3x200, a 3-channel, so red, green, blue, and a 226 image. So a square, 3 colored channels, yeah. When you load and transform it, you'll get a tensor shape of 3 and then 226. Your model, though, is expecting input shape of n, which is batches, 3, 226, where n is the number of images in the batch. So, do you make a batch of 1? So, how do you make a batch of 1? Okay. So that's what that's about. Reshape may sometimes clone for tensors that are... Okay. Unsqueeze. Unskew EEZE 0. It's going to add a dimension, right? So that adds a dimension. It basically adds another bracket. And if you just unsqueeze this a whole bunch, watch this. So you could do a whole bunch of unsqueezes. And it just keeps adding more brackets. Right? As many brackets as you want. Just keep unsqueezing. Brackets everywhere. Brackets all day long. Can you do squeeze? To bring it back down. Oh, look at that. It brought it all the way back down. That's pretty neat. I didn't know you could do that. That is pretty neat. What, can we put a number in there? Or is that, it can't be a float. Okay, that's fine. Look at that. Unsqueeze 4. What about 44? Too many unsqueezes. Okay, 10. All right, 14. 19. All right, I don't know what that number is, but if you unsqueeze it, it's all the way there. It's all the way there. AI maxing. Oh yeah, AI maxing all the way to the max. This is your ChatGPT comment. We'll be laughing humor because Claude says I'm ChatGPT beta user, but you know I'm human. As far as I can tell, you're human because there's several indications that you're human. We got several indications there. All right. What if we unsqueeze it differently, though? Here's what I want to know. Can we unsqueeze it differently? So what if we unsqueeze on 1? How does that do it? Unsqueeze 0. Oops. Darn it. All right, we'll have to redo that. 0, so 0, 1, and 2. There you go. Okay. So you can see here where the dimension is being applied. Reshape. Okay, now we're in the reshape section. All right, let's try this. Let's do the reshape. Okay. So this is the reshape tutorial that we wanted to get into. Here we go. All right. A equals torch.rand, and we'll go some big dimension, 6, 20, 20. Print out dot shape. This will be Python tensor reshape. There we go. Okay. And then we're going to input 1D. So we can reshape. Oh, interesting. So this will convert every single dimension into a single string. I have been wanting something like this for a long time. I've needed this before, and I've done it manually. Doing a reshape is actually pretty nice. Shape will return a view on the tensor to be changed. All right. Let's see, transpose, view, and reshape. Often errors works may copy. Oh, okay, that's exactly what Neva said. A transpose tensor classic view may fail because the stride no longer matches the requested shape. Okay. So you can use a reshape and it will always work, usually. And it may do a copy. Often errors. Huh. All right. Well, it was the same for me either way. So apparently you want to use view when you can, because it's going to be guarantee like efficiency, and use reshape when you really, really need it. 2023 version, unless you clone it. There are conditions beyond scope of the introduction where reshape has to return tensor carrying a copy of the data.